Hello, today we're doing section 2.2, solving linear equations in one variable. The objectives of this function are to solve equations by using reverse order of operations and solve equations for a specified variable. Section 1, solving linear equations in one variable. Recall, solving an equation means finding all the numbers that make the equation true when substituted for the variable. Given an equation, we know that we can create an equivalent equation with the same solution set by applying the same operation to both sides. We can use this process to solve equations. Specifically, our goal will be to isolate the variable so that it is alone on one side of the equation and absent in the other side. So how do we isolate the variable? We use inverse operations to isolate a variable. So if there's addition, the inverse operation is subtraction. If there's division, the inverse operation is multiplication, so on and so forth. And you also use reverse order of operations. So you start by undoing addition and subtraction, then undoing multiplication and division, then undoing exponents. That won't be covered until much later, and then finally by removing parentheses. Backwards, so it's from the outside in. So example 1, solve each of the equations below by isolating the variable. And it's really a good idea right now while you're getting the hang of it, practice being explicit about the operations you are performing to get from one equation to an equivalent equation. Notice how we are using inverses to undo operations. So for the first one, x plus 3 equals 7, I want to get the x by itself, so I need to do the opposite of plus 3, which is minus 3. And whatever we do to one side, you must do to the other. So then we get x equals 4. And it's always a good idea to check your work. Remember, to check your work, you take the variable and plug it back in. So we get 4 plus 3. Does that equal 7? Well, 4 plus 3 is 7, so yes, it works. 2x equals 9. So we have 2 multiplied by x. So to undo multiplication, we divide. So then we get x equals 9 halves. And again, to check our work, I'll take 2 times 9 halves. Does that equal 9? Well, because how fractions works, the 2's cancel out. And we are left with 9 equals 9. So x equals 9 halves is the answer. 5x minus 9 equals 11. So I need to undo the multiplication by 5 and the subtraction by 9. And if we're thinking of our order of operations, normally we would do multiplication first, but because we're solving the equation, we're going to go backwards, so we're actually going to take care of the subtraction first. So the opposite of subtracting 9 is adding 9. So that's the first step we'll do. We get 5x equals 20. And then the opposite of multiplying by 5 is dividing by 5, and we get x equals 4. And I'll let you guys check on your own that 4 is a solution to that equation. Example 2, solve each of the equations below by isolating the variable. When the variable appears more than once in a linear equation, we must first simplify both sides and then add or subtract one of the variable terms from both sides. Only then can we undo the operations on the only instance of the variable. In other words, you need to get the variable on one side first before you try to isolate it. So 3x minus 6 equals 15 plus x. So in order to do this, I want to get the variable on one side. I have a 3x and I have an x. My recommendation is you always try to cancel out the smaller one. So since x is smaller, to cancel out a positive x, I subtract x. But whatever you do to one side, you must do to the other side. So 3x minus x is 2x. Then nothing happens to that, so minus 6 equals 15, and then the x minus x cancels out. Now that there is only one variable, we work on isolating it. So we add 6 first. Get 2x equals 21. And then we divide by 2. X equals 21 halves. And I'll let you check that answer on your own as well. Well, now with this next example, we have 7 times x plus 1 in parentheses equals 5x minus 10. Now 5x seems smaller because that is like a 7x, but I can't subtract 5x right now. So the first thing you have to do is distribute the 7. So we get 7x plus 7 equals 5x minus 10. And again, because there's 2 variables, you want to cancel out the smaller one. So to cancel out 5x, we're going to subtract 5x from both sides. Then we get 2x plus 7 equals negative 10. And then we go through and subtract 7 from both sides. And we get 2x equals negative 17. And then divide by 2 on both sides, we get x equals negative 17 over halves. Example 3. Solve each of the equations below by isolating the variable. If there are any fractions or decimals, you can clear them first. Now, to clear a fraction, multiply by the LCD of all the fractions. And to clear a decimal, multiply by a power of 10. And when we get to the examples, I'll explain what I mean by that, but powers of 10 are like 10 to the first power, 10 to the second power, 10 to the third power. And it will be determined by the number of decimals. If there are any parentheses, just like in the previous example that we did first, you want to distribute to get rid of the parentheses first before you try doing these 2 steps. Okay, so x over 4 equals negative 5. Well, there's only one denominator, so the LCD is 4. We multiply both sides by 4. We get x equals negative 20. 7.3x plus 2 equals 5. Well, since there is only one decimal point in the 7.3, I'm going to multiply by 10 to the first power, or 10. So multiply everything by 10. Because that will move the decimal place over, giving us 73x plus 20 equals 50. Subtract 20. 73x equals 30. Divide by 73. X equals 30 over 73. And that can't be reduced. Okay, the third one. Well, now the LCD between 7 and 7 is 7. So I'm going to multiply everything by 7. Now, when I'm doing fractions, I actually do write it here because it makes it more clear what we're doing. Where I'm going to write the multiplied by 7 next to each term. Because the 7s will cancel out there, leaving us with 2x. But then 7 times 1 is 7. and the 7s will cancel out here, leaving us with 4. Then you go through and solve it like we would. So we need to cancel out that 7, so subtract 7. 2x equals -3. Divide by 2, divide by 2. We get x equals -3/2. Okay, so here the 1.3 has 1 decimal place, but the 1100ths has 2 decimal places. So we're going to multiply by 10 to the 2nd power, which is 100. So multiply by 100, multiply by 100. So that moves the decimal place over 2, so that becomes 130x minus 100 equals 100x plus 11. Now I do have x on both sides of the equation, so I do want to cancel out the smaller one, which is 100. So I'm going to subtract 100x from both sides. Get 30x minus 100 equals 11. Add 100 to both sides. Get 30x equals 111. And divide by 30, divide by 30. X equals 111 over 30. And there's your answer. Part 2 of the notes. Solve for a specified variable. The big idea is to treat the formula like a regular equation with the goal variable as the only variable and the other variables like numbers. Solve as usual. So for this one, we have x plus 2y equals 97, and we're solving for x. So that means we want to get x by itself. So in order to get x by itself, I need to cancel out the 2y. So to cancel out the 2y, I subtract 2y from both sides. Then we get x equals 97 minus 2y. And x is by itself, so we're good. For the second example, we want to solve for y. So I need to get y by itself. So in order to get y by itself, I need to get rid of the x and the z. So I'm going to subtract 3x. I'm going to add z at the same time. It's okay to do more than one term at a time. Now, you would never add and multiply at the same time, but since this is subtraction and addition, it's okay. So then we get 5y equals 19 minus 3x plus z. And when you divide by 5, don't forget you have to divide everything by 5. And because none of these have a 5 in it, it's okay to just leave your answer like this. Y equals 19 minus 3x plus z over 5. And that is it for section 2.2.